Learn more about rationalizing denominators, and I have some practice questions for you. I've already written some of the notes, and if you need to pause at any point to read them over, feel free to do that, and also feel free to pause so that you can try working the examples before you see my solutions. First of all, to rationalize means to make rational. We need to understand what rational is. A rational number is a number that can be written as a quotient of integers. Here's some examples. Decimal 4 can be written as a quotient of integers, 4 over 10. Decimal 3(1) likewise. Decimal 5 repeating can even be written as a quotient of integers, 5 over 9. So if decimals terminate or repeat, they can be written as fractions. Square root 4 can be evaluated and simplified to 2, which is 2 over 1. Even something like cube root of negative 27 is the number negative 3, and it can be written as a fraction. All of these are rational. So examples of things that aren't rational, they're irrational. Numbers like root 2, root 3, root 5, 6, and so on. Notice that I don't have root 4 here, and I don't have root 9 here, because those can be simplified. Anytime that you have a number that's not a perfect square in the square root, you've got an irrational. The same holds for things like cube roots and so on. If these aren't perfect cubes, they'll be irrational. Alright, now that we understand what that's about, here's the next thing to remember. To make something like root x rational, multiply by itself. Multiplying by itself is the exact same idea as squaring. And squaring and square rooting are inverses. So root 2, if I had root 2, if I multiply by another root 2, I get the number 2. Root 5 times root 5 makes the number 5. This is a way to make monomial factors rational. Multiply by another one of the same thing. Another thing you need to recall, how to expand different types of products. This is the distributive property. A multiplied by b plus c expands this way. Generally, if I have a binomial times a binomial, I use a process called FOIL. It's an acronym to remind us first terms, outer term, inner terms, and last terms, which is what I've written here in this expansion. Now, sometimes there's a special case that occurs, and this one's a very important one to know about. The special pattern is this binomial times this binomial, where the second binomial has the opposite sign of the first one. It's called the conjugate. The expansion is written here, and you'll notice the second and third terms are signed opposites of each other, and they'll cancel out, leaving a difference of squares, a squared minus b squared. Now this matters because squaring square roots will get rid of square roots, like we observed up at the top here. So the next thing you need to get good at is using conjugates, understanding what a conjugate is and how to multiply with it. So we're going to use that pattern right at the top of your screen there. I'll keep it on the screen. And you could try this right now, right beside here, the root 6 plus root 2. What is its conjugate? Pause it and try it. The answer is root 6 minus root 2. So, same binomial, switch the sign. Now, if we use the difference of squares pattern, I would get root 6 squared minus root 2 squared. And that's from up here. Observe this pattern up at the top. That's the number 6 minus the number 2. So my answer is a rational number, 4. That's my goal when I multiply by conjugates of radicals. Try the second one. You may want to start it all the way and run it through and see how you do. Pause it. Your answer is root 5 plus root 3 conjugate. The expansion is root 5 squared minus root 3 squared. It's always a minus sign there. That's the number 5 minus the number 3. This answer is 2, again rational. Let's try the next one. Conjugate is root 7 plus 2. Expansion, root 7 squared minus 2 squared, which makes the number 7 minus the number 4. This is 3. A little bit different structure than the earlier ones. They don't both have to be radicals. Part D is also different. These are mixed radicals. There's numbers outside and inside. Write your conjugate. 3 root 5 plus 2 root 3. The expansion is 3 root 5 brackets squared, all of it gets squared, minus 2 root 3 brackets squared. This makes 9 times 5 minus 4 times 3. Don't forget you square the number outside and the number inside. That's 45 minus 12. It's going to make the number 33. In every case, the numbers I've boxed are rational. Alright, here's how we take advantage of this. Rationalize these and simplify. Now, notice I've taken advantage of the work up above. Root 6 plus root 2, that's my denominator. Root 5 minus root 3, I've already done these ones. Now, when I'm working with expressions like these, I need to multiply by 1. 1 is anything divided by itself. I want to use the conjugate. So I have to write the conjugate here as well, because something divided by itself is 1, and I maintain equivalence. Fraction times fraction, I multiply numerator, 1 multiplied by that binomial. The denominator we already observed was root 6 squared minus root 2 squared, so that's 6 minus 2, 4. That's done. You try the next one, you may want to pause for a moment and then see how you do. Alright, I assume you paused and you've got an answer. Root 5 plus root 3 is the conjugate. Root 5 plus root 3, I multiply by 1. Let's do the denominator first. Root 5 squared, 5. Root 2 squared is 3. 5 minus 3 is the number 2. I've rationalized. The numerator is a binomial times a binomial. So FOIL first, outer, inner, root 3, root 5 is root 15, and last, root 3 squared is the number 3. Alright. These are unlike radicals, so I can't simplify or combine them. Root 5 and root 3 are different than each other, so is root 15. They can't be reduced, there's no perfect squares. Even though these have 5s, this doesn't have a factor of 5, so there's no reduction possible. Okay, let's move on. Here's 2 more. Let's move them a little higher. Try doing C. Write the conjugate and the same thing on the numerator. Pause and work the problem, see how you do. Conjugate's root 7 plus 2. I'll write it numerator, denominator. The denominator is root 7 squared minus 2 squared. That's 7 minus 4. That's 3. Numerator. FOIL first, outer, inner, last. Extend that line a little bit. No perfect squares, no perfect squares, no perfect squares. These radicals can't be simplified. They're unlike. They can't be combined. And there are no factors in the numerator that are in common anywhere to reduce with that 3. So that's simplified. One more. Try this problem and pause it for a moment. Okay. Your conjugate is this expression. I'll write it on the numerator and the denominator. So I have 3 squared 9 times 5, 45, minus 2 squared 4 times 3, 12. Numerator FOIL is 3 times 5 plus 2 root 15. That's my first and my outer. My inner, 3 root 15. My last, 2 times 3. Okay, I can do a little simplification here. First of all, the denominator is 33. The numerator, this is 15. This is 6. I can combine them and make 21. This is root 15. This is root 15. They're like. I can combine them. 2 of them here. 3 of them here. I'll write 5 root 15. No common factors. 21 and 33 do. They have a common factor of 3. There's no factor of 3 here. I can't reduce. That's it. That's how to work with conjugates when you're dealing with radicals and rationalization.